Guys, now let's solve this problem. It sounds to be a little bit more complicated to you, but this is very interesting problem. Now in this case, Robert is traveling on his cycle and has calculated to reach point A at 2 p.m. If he travels at 10 km per hour, he will reach there at 12 noon. If he travels at 15 km per hour, at what speed must he travel to reach in the point A at 1 p.m. So in this kind of problems, remember what thing is given. So from a point particularly, they give us to reach a destination which is point A here. Now E can be reached to destination A in a particular speed. That speed can be, let's say here in this case, at 10 kmph. 10 kmph. That speed can be also 15 kmph. 15 kmph can also be possible, and if he uses 15 kmph, he reaches 2 hours earlier. At what speed he must travel to reach this point A at 1 p.m. So what we need to do, we need to construct a equation using this two different statements that he used 10 kmph or 15 kmph to reach A. Then we implicate that value in this final way to get the answer of our question. So let's begin. So we don't know what is the distance actually, from what is the distance he is traveling, but still we know that different variations in his speed and the time duration he can reach. So it's always a better idea for this type of problem to look for let the distance be x kilometer. So the distance traveled by Robert here is x kilometer. We assume that, right? Now what is going to be the time gap? And we know the time gap, right? Because so the time, so if we know this, so the time required if the speed is 10 kmph, the time will require simply distance over speed. Distance over speed. So it is giving us distance is x here, and the speed here is normally 10 kmph, so this is going to give us x by 10. This is the time. Similarly, the time if we calculate for 15 kmph speed, then again the distance remains same x, but the speed varies, which is 15 km per hour. So we get the two different time duration. And according to the question, we know that if he uses 10 kmph, he will reach at 2 p.m. If he uses 15 kmph, he will reach at 12 noon. So the time duration or time gap between these two different speed is 2 hours there, right? So from 12 noon to 2 p.m. So it is only 2 hours gap. And according to our statements, according to our equations, we can also put this in this way, minus x by 15. This time gap is 2 hours, right? So simply you can put it. If you put it in this way, it is going to be 30. So 3x minus 2x equals to 2. So it is going to give us x equals to 60, isn't it? So the value of x is 60. So the distance traveled by Robert here is 60 km, and it is a very important finding for this problem. Now once we know this, what else we can get this from here? We can get the time taken. Now you can easily calculate the time taken if we use 10 kmph. Simply we know the distance by the speed, right? So the distance here we know 60 kmph, and the speed is 10 kmph, so 60. So the answer will be 6, right? So the time taken here will be 6 hours, right? So actually it will be 6 hours, right, in this case. So the Robert started the journey 6 hours before the 2 p.m. Now here comes the most important point. So we understand the process, that 6 hours, and he will reach this point at 2 p.m., right? So he started his journey 6 hours before the 2 p.m., right? So 6 hours before 2 p.m. is going to be 8 a.m. If you calculate it, it's going to be 8 a.m., right? Because 8 and 6 is going to be 2 p.m., right? So once we know this, so required speed to reach there at 1 p.m. So Robert needs to reach there, to be reached at 1 p.m., right? So he started his journey at 8 a.m. He needs to reach there at 1 p.m. So what is the time Robert is having here, the time Robert have is 5 hours, isn't it? Because from 8 a.m. to 1 p.m. it is 5 hours duration. So Robert is now having 5 hours, and the distance to be covered here is the same that we find, that is 60 kilometers. So 60 kilometers is the distance, but the time Robert is now having is 5 hours only. So the required, sorry for the bad handwriting here, required speed here is equals to 60, which is the distance by, let me write it here in this way, distance by time, and distance here is 60 kilometer and the time is 5 hours. So 12 kmph should be the desired and required speed for Robert to reach the destination A at 1 p.m. And here we go, the option C is showing us the 12 kmph, and 12 kmph is the correct answer for this problem. See, in this problem the key thing to understand is to find what is the distance, because in this total problem they neither tell you the distance, they neither tell you the time when Stuart started the journey. So you need to understand these two particular point. You need to get the value of the distance, and second thing, you need to get to know the time Robert start the journey, right? So in this case, once we first find the distance, it is becoming very, very easy to understand the time Robert is having. So if you know both of them, then you can simply divide it by the formula like speed equals to distance over time, and you get your desired speed. So that's it, guys, and I hope that's helpful. Thank you.